Hello fellow nerds, welcome to Nerd Chat. I'm your host Steven, Nick's your studio producer in the back, and today I'm joined by Dale Jordan. Today I'm joined by Shashir Pandit Rao. Today I'm joined by Advath Nair. And today I'm joined by Bruce Schaefer. Today I'm joined by Mike Matera. Today I'm joined by David Perry. I was also wondering, in your opinion, what differentiates good code and bad code?
Boy, when I was younger, I used to be a zealot on proper coding techniques and documentation techniques, and but I think age has kind of seasoned me because the world, the environments, how we write code, its longevity has changed so much. So I've softened my attitudes about that, and I guess when I look to evaluate something, the first thing is, can I pick up a piece of code and maybe with its documentation that goes with that, can I easily read it and understand what it's trying to do? And the next thing I would kind of look for is, if I wanted to make changes or fix a bug in it, do I feel confident that I could easily go in and do that? And if it meets those two criteria, I say that's good code.
So on the topic of being a Control Award finalist, it must have taken a lot of work to get to that point. What did your team do to receive that award?
Well, I'm not the programmer, so I'm going to start off with that. But there were many aspects, many facets that went into being a Control Award finalist. I gotta say, it was an extreme honor for us, especially because our programmer was a complete rookie. In the beginning of the season, he was having trouble even like creating a teleop because obviously this is the first time he'd interfaced with such a with such a program, and being able to go from that point to at the end of the season, being a finalist of such a prestigious award, kudos to you, John. Just wanted to start off with that. But there were multiple things that we did do to be Control Award finalists. One of the main things that we did was our use of the OpenCV computer vision software, and we combined this with color sensors for the Joule element of the game, and to get the Joule knocked off in under a quarter second, one of the fastest at the World Championships. That utilization of the combining OpenCV with color sensors, as well as being able to have a fairly consistent 4-glyph autonomous, is what I believe got us that award.
What was your team's approach to quality assurance and reliability when it comes to the robot?
Yeah, so our team, out of the 2 SparkTech teams that exist right now, we're known for our maintenance skills and how we maintain a robot properly and consistently, right? So one problem we had at Worlds actually was our IMU broke, and it was in the middle of a match during autonomous. I believe this happened once and it cost us the match too, because he went into the other side's opposing side, got 40 points and penalties, and that's the reason why we lost the match. But because of this very issue, we decided to step it up this summer even more, because we decided to train our members into all these different things, right? So for every match, we have this tester program that we run to make sure every single component of the robot works, including the IMU, because we don't want that breaking again. And other components of the robot, like the Rev Hub, we make sure everything's plugged in properly, if we have time, of course. If there's back-to-back matches, in the league meets, then we're gonna have a bit of trouble with that. But we try to maintain as much as we can, as frequently as we can, and we've done a summer camp in order to do that with all of our members. So it's been turning out really successful so far.
Okay, I was also wondering what advice you would have for students looking for a career in STEM.
I would go by something I heard from somebody even older than me, and that is, if you learn enough about something, you'll probably find some part of it that you enjoy. STEM is an acronym for science, technology, engineering, and math, and each of those 4 disciplines have a lot of subdisciplines. So by exposing yourself to a variety of them, you're going to find a few things that you particularly enjoy, and if you get the right education and have the right tenacity, you'll probably be able to create a career out of it. If you decided it's going to be a different career that's not STEM, what you learned about creative teamwork and science, technology, engineering, and math will probably still help regardless of the career choice.
So what are your thoughts on trade-type education vanishing from schools?
Well, I don't know if that's really true. When I was living in Arizona, I had a job with the community college as a recruiter, and I went around to a lot of the high schools to tell them about careers in engineering and design and things like that. And I was pretty surprised at how well equipped some of their labs were. There were high schools that had little tabletop CNC machines and 3D printers. And this was, 5 years ago. So I guess it really just depends on the school, and it would be nice if if more parents would get involved and see the importance of things like this. You know, I guess a good sports program is nice because it brings people together, and sports are something that's supposed to promote teamwork. I'm not a big sports fan, can you tell? But I think these kinds of skills where the high school has a wood shop or a metal shop where people can actually go make something. There's nothing better than the pride of getting your hands on something and building it yourself and taking it and showing it to other people and say, look, I did this. So I know there seems to be a decline in a lot of programs at a lot of schools. You know, I'm sad to hear that they're dropping band programs because I think music is important, because music, manufacturing, I mean, mathematics is at the core of a lot of this stuff. And not that you have to be good at math, because we're all walking around with supercomputers in our pocket, basically. We have the information of the world available at our fingertips. But it is sad that some schools are dropping some of their programs.
So a lot of first teams don't really focus on pure fabrication. Do you see an advantage in teaching fabrication?
Yeah, absolutely. And I think the tools that are out there now for fabrication obviously make a lot of elements of it much easier. You know, the way 3D printing is really common now. You know, CNC routing. There's a lot of really great opportunities that are making custom fabrication a little bit easier to access for more teams. So I think it's a great way for teams to expand what they're doing with their robot. I think I'd love to see more computer-aided design from students, and that's a good entry point to it, is that custom fabrication of parts and pieces.
Well, that's all the time we have today, nerds. Thank you for joining me today, Dale.
Well, thank you very much for having me.
Thank you so much.
You're welcome. It's been fun.
Thank you for having me, Stephen. I really enjoyed the opportunity to speak with you today.
Thank you for inviting me.